Hello everyone. Hello Professor. I'm Zhenghao Li, and my project is artist recognition. I want to use convolutional neural networks to recognize the author of paintings, and I cut down my dataset to 25,000 paintings by more than 100 authors, and then I will use .NET to train the CNNs to determine the best possible feature representations of paintings. Well, then I tried two architectures. First one is darknet 19, and the author modified the extraction network to be faster and more accurate. This network was sort of a merging of ideas from the darknet reference network and the extraction, as well as numerous publications. They use mostly 3x3 filters and double the work on networking network. They use global average pooling to make predictions, as well as 1x1 filters to compress the feature representations between 3x3 convolutionals, and use batch normalization to stabilize training, speed up convergence, and regularize the model. The next one is ResNet 18. The reason I choose this architecture is because the other research use this architecture, so I want to use it as a comparison. And the ResNet 18 is a convolutional neural network that is 18 layer deep, and use residual blocks to ensure that upstream gradients are propagated to lower network layer, aiding in optimization's convergence in deep networks. But the author of .NET said it's slow and not precise. Then look at my experiments. My experiments almost done on my PC. And my procedure is just modify the CNN architecture, mainly about the feature numbers and the batch and subdiversions, and then clean data and generate labels and the training classifier and detector, and validate the data and visualize the results. First, let's say the classifier for artists. Because there are more than 25,000 paintings and more than 100 classes in dataset, and it's a classifier I cannot label for each painting, so it's very hard. It doesn't work. My main work is train several textures for artists. For both of .NET 19 and ResNet 18. I set the batch is 256 and subdivisions is 16. After 1,000 times training, approximately more than one whole dataset, then stop training and lower the whole learning rate. But the learning rate of last convolutional layer will be larger than others. Training after 100 times, I will set all learning rate equals 0, only leave last layer a small learning rate. Okay, let's see the results. Left side is .NET 19 and right side is ResNet 18. The loss lower down very fast at beginning, and after 1,000 times training, I lowered down the learning rate. MAP should be more gentle, but it goes up fast, so it's a little strange. Okay, and then let's compare the result with other research. It's a result from Stanford University. They trained the model with PyTorch, use ResNet 18, and they have the more than .9 accuracy, training accuracy, and around 80% test accuracy, but I only have around 70% training accuracy and lower test accuracy, so my result is not good. But I still have some plan, and I should do more. I think I've also trained a detector for styles, but I can't handle date very well because I want to handle data as continuous, but I can only train it as a label. It's no connection with each other years. Then I want to combine multiple outputs, then modify the input by itself. The next thing is I want to try to use LDA to optimize the results. Okay, thank you everyone. That's all.